This video here is a nice problem is coming from the Polish Mathematical Olympiad edition 1994. Here is the following statement. Find all EB as a natural numbers. Satisfy these following fractions. We have A plus number 1 over B is a natural number. Also B plus number 1 over A is a natural number. So we are going to work out on this one in order to find the appropriate value of A and B to make both terms as a natural number. Okay? You may solve this one in different ways. You can give the hands to us from prior into the solution. Go ahead, pause this video when we come back to see the full solution. Okay. By the way, don't forget to hit the subscribe button and support the channel. So let's jump into this one. So we get A plus number 1 over B. So we get A plus number 1 over B. We get A plus number 1 over B is a natural number. Let's set this one equals K1. This one equivalent according to the divisibility definition. So we get A plus number 1 is a congruent to 0 mod B. This one equivalent to A plus number 1, which equals K1 is multiplied by B, where is K1 is a natural number. Okay. Also, I'll have the same argument for the second one. I get B plus number 1 over A, which equals K2, equivalent B plus number 1 is a congruent to 0 mod A. And set to have B, we have A here. Also, this one equivalent to B plus number 1, which equals K2 is multiplied by A. Okay, whereas K2 is a some natural number. So we get this expression here. So I'm simply going to move over this number 1 to the right and leave B to the left. I will have the following. When I get K2 is multiplied by A minus number 1, which equals B. We know B is a congruent to 0 mod B, because we get B is divisible by the same number. So now, I have ended with this nice expression. Let's name this one as a expression number 3. Next thing up, if you take a look at both statements, we get mod B here, we get mod B here. Now also we get number 1 here minus number 1 here. If I'm going to add this one on this one, I get number 1 cancelled out, and also I get A, it can be taken as a common factor. So let's do that. So by adding number 1 plus number 3, I get here A will be factored out. I get A is multiplied by K2 plus number 1, which is a congruent to 0 mod B. It's very simple. So what's this one telling us? It's telling us B can divide A or B can divide K2 plus number 1. But remember here, if you take a look at here, we get B divides A plus number 1, which means B cannot divide A, because A plus number 1 and A are prime numbers. So since we have GCD of A and A plus number 1 equals 1, because they are prime, which means B not divides A. If B not divides A, which means B must divide this one. B divides K2 plus number 1. So according to the divisibility statement, I get here K2 plus number 1, which equals M is multiplied by B. So I have ended with this nice expression. Let's name this one as the equation star. Okay. Also, let's name this one as a double star. Okay. If you take a look carefully here, we have K2 here is multiplied by A, but we have only K2. So in order to make the combination between this equation and this equation, I'm simply going to multiply both sides of this equation by A. Okay. So let's do that. So I get A is multiplied by K2 plus A equals MBA. So now, since I get A K2 here, I'm going to insert this one into this one with its value. So this A K2 will be replaced with B plus number 1 by this fact. Okay. So now I will have the following. I will have the B plus number 1 plus number A which equals mb is multiplied by a. Okay, so now we get a here, we get a here. Now I'm going to move over this a to the right and leave b plus number 1 at the left side. So I get here the following. I get b plus number 1, which equals a factor mb minus number 1. Okay, so let's divide both sides by mb minus number 1. I get a, which equals b plus number 1 all over mb minus number 1. So we have end with this nice expression. As we know, since a is a natural number, which means b plus number 1 as a numerator is always bigger or equal to denominator. So I get the following. I get, since you get this one as a natural number, which means always denominator is smaller than numerator. So I get mb minus 1 is inferior or equal to b plus number 1, like this. Okay, so the next thing up, I'm going to move over b to the left and move over this minus 1 to the right and take b as a common factor as well. So I get b factor m minus number 1, which is inferior or equal to 2. Okay, so now I have ended with this nice expression. Now let's take this one at the top and continue solving this one. Now we have to go through two cases. We have the case number 1, if we have this product equals 1 or this product equals 2. Let's start in with case number 1. When we have this product equals 1. This product equals 1, it simply is going to give us b equals 1. We don't care about this one, we care only about the value of b, because that's what we have to use here. b equals 1 is going to make both fractions as a natural number. We are simply going to check it in the second fraction is enough. Okay, so plug in here number 1 here into b. I get 1 plus 2, which is 2 over a. I get 2 over a. This one must be a natural number, which means a belongs to this set 1 and 2. Okay, so if a equals 1, I will have a first solution, a equals 1 with b equals 1. So I plug in a with number 1 here, get 1 plus 1, which is 2, 2 over 1, which is natural number. Also the second one, I get 1 plus 1, which is 2 over 1, which is natural number also. So we get the first solution. Let's check if you have a equals 2. I will have the same thing. Plug in here number 2, you get 2 plus 1, which is 3, 3 over 1, which is 3, is a natural number. Also the second fraction, you get 1 plus 1, which is 2, 2 over 2, which is 1, which is a natural number also. So I get the second solution, a equals 2 with b equals 1. Okay, let's go through the second case when we have this product equals 2. So this product equals 2 implies b is going to take two cases, b equals 1 or b is going to take number 2. Because if b equals 1, which means this one equals 2. If b equals 2, this one equals 1. So for b equals 1, we don't need that because we already have a solution for that. Now we are going to take off this one from here. We are going to leave only this one. So we get b equals 2. So b equals 2 is enough to check it in the second fraction, because I get 2 plus 1, which is 3 over a. This one must be a natural number, which means a is going to be in this set 1, 2 and 3. Let's go through each one, but be careful here, we are working on b equals 2, so it doesn't mean we are not going to consider the previous solutions, because we have changed b here into 2. Okay, which means we are going to check this one individually. For if a equals 1, I'm going to insert this value of a equals 1 into two fractions to see they are natural number or no. Okay, so for the first one, I get 1 plus 1, which is 2, 2 over 2, which is 1, which is a natural number, which we are good to go. For the next fraction, I get 2 plus 1, which is 3, 3 over 1 is also a natural number, which means we have a solution. We have e equals 1 with b equals 2. This one gives us the solution because of the symmetry reason, because if you take a look at both solutions, you get a equals 2, b equals 1. The other one also we need to have a equals 1, b equals 2 because of the symmetry. Okay, now let's check the next value. If both values are equal to each other, if b equals 2 and a equals 2, we have a problem here. Let's check it. A equals 2 plus 1, 1, which is 3. 3 over 2 is not a natural number, which is impossible. Since this one is impossible, since one is not a natural number, we don't need to go to the next fraction. Okay, we are going to stop here. So let's move on to the third value, last one. If a equals 3, if a equals 3, I'm going to do the same thing. Plug in this one, plug in number 3 into here. I get 3 plus 1, which is 4. 4 over 2, which is 2, is good to go. For the next fraction, I get 2 here plus 1, which is 3. 3 over 3, which is 1, which is good to go as well. So which means I have the final solution, which is a equals 3 with b equals 2. Okay, for the symmetry reason, I will have the same thing. We have another solution. We have a equals 2 with b equals 3. Because I have ended this video. By the way, don't forget to hit the subscribe button and support our channel. And thank you for watching. I will see you next video. Bye.